Hi everybody, this is going to be a little bit about indicators and Table M for your assignment that's being posted on April 9th. First of all, this is, and I'm going to move this down here, our pH scale. Little reminder about the pH scale. It runs from 0 all the way up to 14. There's a misconception that 0 is not part of our scale. It is. Our acids are below 7, so 0 all the way up to 6.99 repeating. Neutral is 7.0 and only 7.0. It's nothing greater or less than that. Basic is greater than 7 all the way up to 14. Now what we're looking at, and you can see it right here, concentration of hydrogen ions compared to distilled water. The concentration of your hydrogen ion is how we calculate the pH, which is part of what you're going to be doing. The concentration of hydrogen corresponds to the pH. The more hydrogen ion, the lower the pH, because you can see that if there's more hydrogen, we're going to have a lower pH over here. So we've got a couple examples here, which you're going to be doing in your notes. An acid, we've got a couple definitions of acid. They're both listed here, and you do need to know these. A compound that yields hydronium as a positive ion in an aqueous solution is an acid. So if you end up with a reaction where you end up with hydronium over here, it yields hydronium, that's an acid. Another definition is it donates a hydrogen ion. So you'll see that this right here, H2CO3, donates a hydrogen. How we know it donates is because it no longer has two hydrogens, it only has one. It gave one away. It didn't just disappear, it gave it away to the hydrogen, or to the water. Base, very similar, has two definitions. A base is a compound that yields hydroxide ions. So you'll notice that as we look at this yield, so we're looking after, and hydroxide is one of the components. Now a compound that accepts that hydrogen ion from another species is a base as well. So this is the same equation as acid. We said that this was an acid, and we knew it was an acid because it gave away a hydrogen, which means this water is accepting that hydrogen because it has one more hydrogen on the other side of the arrow. When we look at this, you'll generally have an acid plus a base for these equations. One of the things you're going to be looking at is indicators. Now our indicator table is table M. We have many indicators. There's a pH color change and what the actual color is. So here are your indicators. We have 6 that we're going to be dealing with. Approximate pH for color change. You don't need to know the exact change. You need to know what it starts with and what it ends with. And then here's our color change. And how we read this is methyl orange. It says red to yellow. So we start at red. So I could write in the word red right here. So it's red from 0 to 3.1. And then it changes to yellow during this time frame. And then it goes from yellow from 4.4 all the way on up, which is what I have written here for you. pH is 0 to 3.1. The color is red, the first listed here. The color change is here. Now, this is an art class. If you know that yellow and red make orange, you can write orange, or you can say that it's changing from red to yellow or yellow to red, depending on if it's getting more acidic or more basic. And then a pH of 4.4 up to 14, it is yellow because this is listed last. It's the higher of the numbers. And this is what it actually looks like. This is a titration with methyl orange, and here it is. It looks pink in just a minute when it starts over. This is the red. It's going through the color change, that 3.1 to 4.4, and our final color is yellow. And here's another one, phenolphthalein. It's a titration, and our phenolphthalein, it starts clear. It's very acidic, and as you can see, it's starting to turn pink. The color is very drastic and quick with phenolphthalein, and it ends pink once the pH is 9 or above. So you can see that it's not completely pink here. Once they zoom in, once it stays pink, then it's pH of 9 or above. Just because you see those little drops of pink doesn't mean it's a higher pH. It's just mixing in. That's why they're swirling and swirling and swirling. Okay? And this is a titration that you would do if we were in school. However, we are not, and so therefore you don't get to do it. I hope that your homework goes well. Bye-bye, everybody.